Now, as we were solving percent problems, we ran across an interesting variety of number. And this variety of number was numbers that we did not know the value of yet. Values that were unknown. What number? And in episode 10, when we were solving percent problems, we represented those unknown numbers with question marks to remind ourselves we don't know what is the value of this number yet. Hopefully, we can figure out what value it is. Here in episode 12, and for the remainder of this class, we are going to be doing a lot of work involving these numbers that we do not know yet, numbers that are unknown, numbers that are question marks. In mathematics, when we're working with a number that is not yet known, or a number whose value can potentially change and shift over time, those unknown values are called variables. A variable stands for a number which is unknown or which might be changing. Now, when we were doing percent problems, we used question marks to represent unknown numbers. But it's also common in mathematics to use letters from the alphabet to represent unknown values. For example, you might see X or Y or Z sometimes. You might see A or B or C sometimes. If you're working with a real life problem, you might see letters that stand for physical quantities. For example, you might see the letter T if it is standing for an unknown time. Or you might see the letter L if it is standing for an unknown length. Or you might see the letter W if it is standing for an unknown width or something like that. You might see letters that are standing in for the first letter of the word that represents the quantity that you're dealing with. Now let's talk about how we write down expressions that involve unknown numbers that are represented by variables. In mathematics, an expression is a combination of operations like plus, minus, times, division, exponent, etc. Numbers like 2 or minus 5 or 1/4 or 0.25, etc. And variables that represent unknown numbers like question mark or x or a or l or t or whatever. When we say in math an expression is just a combination of these kinds of symbols. So, for example, if I said I'm thinking about 2 times 3 minus 5, this would be an expression because this is a combination of the numbers 2, 3, and 5 with the operations multiply and subtract. Another example of an expression would be something like x plus 7. Because I don't know what the number x is, but when you figure it out, once you figure out what x is, add 7 to that. Here's a combination of variables, addition, and numbers. Expressions like this one usually are used to represent quantities that you will calculate later once you know the value of all the unknown numbers that are being represented by variables. And to give you an example of a real world quantity that I think is very closely related to an expression like this one, if you've ever had to look at a tax form, when you filled out a tax form, you'll see a bunch of instructions that look like this. They will have, okay, whatever you earned, put it into box 1. And then what other tips or stuff that you had, put it into a couple of other boxes. Now, we don't know how much you earned from your job. We don't know how much you got in your tips. But however much you got from all these income sources, what I want you to do after you fill in the blanks of those is I want you to add together all of the numbers that you will put in these boxes. So I think that this would be sort of a real life example of a mathematical expression. We have some unknown numbers here that will be filled in later when someone goes to actually do their taxes later. And then as soon as those values are plugged in, later on, that person would then add together all of those income sources. So that's a calculation that would be completed later once these unknown values are known. So let's do some examples of writing down expressions that reflect calculations that we would do later once we know all of the unknowns in the situation. So, for example, I know that Jason is 9 years older than I am, but I'm not going to tell you how old I am. My age is going to be represented by an unknown, a variable, and maybe, for example, I'll use the letter X to write down my unknown age. If I wanted to calculate Jason's age from mine, what expression would I write down to capture how somebody would calculate Jason's age from my age if they ever figured out how old I am? Well, over on the side, I'll do a little thought bubble. If Sam were 38, say, I'm not saying I'm actually 38. I'm saying suppose maybe I was 38. If I were 38, how old would Jason be? How would I figure his age out from that? If I were 38 and Jason is 9 years older than me, then I could find Jason's age by taking my age and increasing it by 9, right? 38 plus 9. That is the action that I would take to calculate Jason's age from mine if I knew what my age was, right? But I'm not telling you what my age is, so you're just going to have to leave my age unknown, represented by a variable x. And if you ever figured out what my age was, the action that you would take to find Jason's age would be to take mine and add 9 to it. So this expression, take Sam's height and add 9, would be the directions that you would follow to calculate Jason's age based on mine. Let me give you another example of writing down an expression containing unknowns here. So if I go into the store and I want to buy, fancy name brand mac and cheese, that'll cost me maybe twice as much as generic brand mac and cheese. Now, when you go into the store, the cost of objects can always change over time, right? Inflation is happening all the time, and the food is just getting more and more expensive, right? So let's represent the cost of generic mac and cheese by a variable called G for generic, to reflect the fact that this price can change over time. Let's write down an expression for the cost of name brand mac and cheese based on the cost of generic mac and cheese. Now, again, off to the side, let's just suppose for a minute that I knew the price of mac and cheese on a certain day. And let's suppose that the generic mac and cheese costs, let's just say $1 for the box. If generic mac and cheese costs $1 and the name brand is supposed to cost twice as much as that, then the name brand would cost 2 times that $1, right? Twice, the keyword twice, means multiply by 2. The cost of the name brand in this particular case would be 2 times that $1. However, I'm in a scenario where the cost of mac and cheese can change, can vary. So it might be $1 one day, but it might be $1.25 the next day. It could vary. So leaving the price of mac and cheese as a variable, if I wanted to calculate the cost of name brand mac and cheese, I would just have to multiply by 2 whatever the cost is of the generic mac and cheese on any given day. 2 times G. 2 times G would be the process that I would use to find the cost of the name brand mac and cheese based on this information. So my coworker Jeremy, maybe he is very financially responsible and he saves 20% of his income. But I don't know how much money Jeremy makes. So I'm going to represent Jeremy's income by an unknown. I'll call it capital I. What if I wanted to write down an expression that represents how much Jeremy saves? What expression can I write down to represent Jeremy's savings, even though I don't know his income right now? Well, suppose for a minute I did know his income. If Jeremy's income I knew was like $80,000 or something like that, how would I calculate his savings based on that information? His savings is 20% of his income. His savings is 20% times his income. So I would calculate his savings by taking 20% times, in this specific case, 80,000. Or put another way, as a decimal, 0.20 times 80,000. But I don't know Jeremy's income, and it can change from year to year anyway. So if I wanted to set up an expression that I could use later on to calculate Jeremy's income when I had more information about it, I could write down 0.20 times whatever his income is in that moment. I would perform the same activity. I would still do 0.20 times his income. I just have a letter there, I, to represent the fact that I don't know his income right now. Now, my mom, Kim, is going out. It's fall, and all the apples are ripe. And so my mom goes out to pick some apples off the various trees. And let's suppose that Kim is going to give these apples away, and she's going to distribute them and share them equally among 5 of her coworkers. Now, I don't know exactly how many apples my mom is going to pick from the tree. So I'm just going to call that variable A. A stands for apple. If I call the number of apples A, let's write down an expression that represents the number of apples each coworker would receive. Now, if I have an amount of apples and I want to distribute and share them evenly among 5 people, to figure out how much each person would get, I would divide. I would divide the number of apples I have by the number of coworkers I have. The number of apples is currently unknown, and then I would divide that by the number of coworkers. A divided by 5, or put another way, A divided by 5. This expression would represent the action that I would take to figure out how many apples each coworker is going to get. As soon as I figure out exactly how many apples Kim has picked, I can then complete this calculation and divide that number of apples by 5 to figure out how many apples each coworker will receive. Now, a quick little note about notation of expressions that involves multiplying together a number and a variable. If you multiply together a number and a variable, there is a special way to represent a product like that. If we multiply two numbers together, there were only sort of three different ways to write that. You could do 2 and then a little cross and then a 3. You could do 2 and then a dot and then a 3. And then you could do 2 and then parentheses and a 3. However, if you're multiplying together number and variable, we can represent a multiplication just by putting the number and the variable next to each other. So if I wanted to write 0.2 times I could also just write 0.2 directly next to I. Or if I wanted to write 3 times G, I could also write 3 directly next to G. Let's talk about expressions involving opposites and reciprocals. Let's remind ourselves from episode 2, part 3, about opposites. When we were taking the opposite of a number, the opposite had the effect of changing negative numbers to positive numbers and changing positive numbers to negative numbers. And the symbol that we used to represent opposites was basically just this minus sign. An extra minus sign written in front of your number is what told you symbolically to take the opposite of your number. So if someone says, I have an unknown number, which I'm going to represent by x, can you tell me what expression would represent the opposite of x? To represent the opposite of an unknown number x, all I would have to do is put that opposite symbol, that tiny little minus sign, out to the front of the x. Same as it would be as if we were taking the opposite of 2, I would put a minus in front of the 2. Here, the opposite of x, I'm putting the minus in front of the x. As well, someone says, what is the reciprocal of x? What expression could I write down to represent the reciprocal of an unknown number? Now let's go back to episode 5, part 2, when we first talked about reciprocals. If I wanted to take the reciprocal of a number like 4, then to take the reciprocal of a known number like 4, I basically just flipped it into the denominator of a fraction and put 1 in the numerator. So if the reciprocal of 4 was represented by 1 over 4, the reciprocal of the unknown number x could be represented by 1 over x. This expression says, when you find out what x is, take its reciprocal by putting it in the denominator of a fraction that has 1 in the numerator. Alrighty, and a little bit more practice writing down expressions involving unknown numbers. We have two people who are taking a quiz. Julisa's score on the quiz is 95%. Stephen also takes the quiz, but we don't know what Stephen got. Stephen did not tell us what his quiz score was. If I ever found out what Stephen's score on the quiz was, what would I have to do? What actions would I have to take to find the average of these two scores? Well, I remember from episode 11 that when I was finding the average of a collection of numbers, I started by adding the two numbers together. And then once those numbers were added together, I would divide by the number of numbers that I had. So let me perform those same actions on Jaleesa's score and Stephen's score on the quiz. Jaleesa's score on the quiz is 95%. And then I would add her score to whatever score Stephen received. I don't know what that is though, so I'll write down just this letter S to say add Jaleesa's score 95 to whatever Stephen's score is S. And once you've done that, to finish averaging these two numbers, I would just divide by the number of numbers that I have averaged. In this case, I averaged two numbers, Jaleesa's score and Stephen's score. So this expression, 95% plus S over 2, would be the expression that represents the average of these two scores.